So, welcome everybody. I see some people coming in still, but I think I will be starting by introducing myself. My name is Edwin van Wijk. I come from the Netherlands. I work there as a principal software architect for a company called InfoSupport. And I'm also a Microsoft MVP in the developer technologies category. And today I want to talk to you about how you can build high-performance event-driven distributed systems using NATS. Just by show of hands, how many people have heard of NATS before? Okay, not that much. Cool. The session is going to be pretty simple. First, I'm going to do an introduction of what NATS is and how it works. There's also something that's called NATS streaming. That's kind of an addition to NATS, which gives you some additional capabilities. We're going to look at that afterwards. And then I'm going to give a demo of an event-driven application that I've built, a small demo. And I've used NATS and NATS streaming in that demo to show you how you can use that. That's at the end. But first of all, let's dive into what NATS basically is. Well, NATS is a messaging infrastructure. So it is built to send messages between parts in a distributed system. And it's really geared towards high performance, high throughput, and all that kinds of stuff. It's very lightweight, and you can build distributed systems with this. It is designed to be really resilient and highly available. So if you have a cloud-native application that has several parts that need to talk to each other, then NATS can be that infrastructure that is always there. Sometimes it's referred to as the dial tone for your application. So if you need communication, it is just there. And I will show you how NATS does that in this session. It's completely written in Go. I believe that the initial version was in a different programming language, but some time ago, the creator of NATS rebuilt it entirely in Go. And this is also why it's so damn performant. It is completely open source. You can find all the code that, if you go to the GitHub repo that I've shown here, all the code is there. And it's also a Cloud Native Compute Foundation project. NATS is pretty mature. We're at version 2.0 now that came out this summer. And it's pretty well battle tested. And why do I say that? Well, originally, NATS was built as the messaging infrastructure beneath Cloud Foundry, which is basically a cloud provider. And the entire control plane of Cloud Foundry worked with NATS. So there were all sorts of messages going back and forth there. If you want to use NATS in your own software, because this is just a server running somewhere that you can use, there's probably a client library available for your programming language or for your platform. These are a couple of the supported clients. They are supported by the creator of NATS. And as you can see here, that's a vast array of programming languages and systems. And the demos that I'm going to show you today are all .NET Core, so I'm using the supported C# client library, but there are lots of libraries out there. And then there's a couple of community supported clients that were created by people from the community. And well, that's a vast array. So probably there's something in there for you. If you want to write your own client, that is also pretty easy because NATS has a very simple text-based protocol over TCP basically. And you even can communicate with a NATS server using Telnet. It's that easy. So this is why there are lots of clients out there. And if there's not a client for your environment, you can just build it. So that's not pretty hard. What are the features of NATS? So like I said, it's a messaging infrastructure. I explicitly don't call it a message broker because it's a little bit different than that, and we will see why that is. But you can compare it, of course, with things like RabbitMQ or Azure Service Bus, but it doesn't have all these features that those other brokers do have. Because it's really designed to favor simplicity and performance over features. So all the cool things that you have, like filtering, content-based routing, a complete management portal, all that kind of stuff that you see with the more widely used message brokers, that's not in NATS. It's just basically high-performant messaging, and that's it. And if you look at the feature set that NATS give you out of the box, you recognize that. For instance, if you don't do anything, you just have at most once message delivery guarantees. So messages will probably arrive at the receiver, at the consumer. So you have to also take this into consideration. So using NATS, and this is a very, very big disclaimer up front, it is a very cool technology, but you're taking on board a couple of trade-offs. It is fast, but it doesn't have all the features that you might need for your application. So it depends. Really check if it's fit for your environment. Also, there's no message persistence. So if you see, that's also why I don't call it a broker. If you, for instance, send a message to a RabbitMQ topic or whatever, it will stay in a queue, and then if the client comes online, it will get this message from the queue and will handle it. This is not the case in vanilla NATS. If you send a message and the client is not connected at that point in time, it will not get the message. So that's really a good thing to understand. There are ways around that, and NATS streaming, for instance, is something that will help you with that, but we will get into that a little bit later. If you look at how you send messages, it is just pure pub/sub. So you send a message to some central point, and there are 1 or 0 or more subscribers listening to that. I don't know who they are, but they can pick up the message and then handle it, but it's pure pub/sub messaging. And this central point that I was talking about, that is called a subject in NATS. So if you, for instance, look at, well, again, RabbitMQ, you have topics and queues and different kind of topics, fan out and direct and all that kind of stuff. That's not in NATS. You just have a subject, you can send a message to it, and you can receive messages from it. That's basically it. One of the biggest things that came in 2.0 version of NATS this summer was a lot of additional security mechanisms. So because it's so simple as a protocol, they've added all kinds of different ways in which you can configure security and make a secure connection with tokens, username, passwords. There's all kinds of stuff in here. And it's pretty well documented on the website of NATS. We're not going to go into this in detail in this session, but know that it's here. So you can get secured connections between producers and consumers. Yeah, that's basically an overview of the feature set of NATS. And the point I want to drive home is basically this trade-off that you get. So it is fast, it is really cool to work with, it is easy to work with, but you don't have all the features that you would expect from a message broker. The simplicity even goes on further because I have basically 2 slides about running a NATS server. It's just distributed as a single executable. As I said, it's written in Go. You just download an exe on Windows, and you start it. And then you have a process, and it's running. It's listening on a certain port, and that's it. And you have a NATS server, a single one. Of course, there's also a Docker image available, so you can pull that and then run it as a Docker container. And this is, of course, pretty easy if you start working in the cloud, for instance. You can just distribute it as a Docker container. And basically, that's it. And there are a couple of configuration settings that you have, like, for instance, the security settings that I just showed you, what the port is that it needs to listen on, all those things that you expect from a server. You can just do that through the command line if you start it as a process, or you can pass in a configuration file. Also, this is all basic stuff. It's all described on the website, so I'm not going to go into that. And then it becomes interesting, because if you have a single server up and running, then of course it could be fast and it could be a high throughput, but it's not available, because if that one process or that server crashes, then you're down. Well, a really cool thing is that NATS is really good in clustering, and this is where the power of NATS really comes to mind, because you can cluster several NATS servers, also on different machines, and then you get kind of a high available mesh of NATS servers. And the really cool thing is that these servers start communicating with each other about the topology. So if another server comes in, you can say, okay, this is another server, and it will tell all the other servers that it's available. So that's pretty cool. So this mesh is automatically maintained by NATS itself. And the even more cool thing is that all these topology changes are also communicated with all the connected clients. And this is really important, and this is also, from a developer perspective, this is really easy, because this is what makes it this dial tone, right? So you just send the message, and the client knows about changes in the topology. You don't have to do anything for that. That's all baked into the client library. So I created a little animation to make this more clear. Let's say I have in this case, I have a mesh of 2 servers, which is not, of course, ultimately available, but I have a client connected to each of these servers. And if I would now stand up another NATS server, it would communicate with the other services, and it will automatically be added to the list of services, which is pretty cool. This is all automatic. You just start it up. You have to tell it where one of the other services lives, and then it will automatically be created, it will automatically be added to the mesh. And if now a client connects, it could even well be connected to this server that we just added, server C. So that's pretty cool. Also, when I connect from a client side and I know which services are online at that moment, it will just randomly pick one for you. So you can also specify multiple. But the really cool thing is that just say that server B will have some kind of a failure, the server crashes or whatever. If this one goes down, because there's all kinds of heartbeats going on, they're going back and forth, so these services are pinging each other all the time, making sure that everyone is alive. So this one dies, its heartbeat dies, and then the servers know that this server is not more reliable anymore, and it will take it out of the mesh. And then this client that was connected to that server knows about the other services, and if I try to send or get a message and get a failure, then the client, the NATS client, will automatically try to reconnect to one of the other services. That's all baked in. You don't have to do anything for that. So this is why this is a highly available solution if you have multiple instances running in a mesh. Yes? Great question. So a question was, will it rebalance if you start server B up again? Yes. Then the same thing will happen. It will be added, but it will be added as a newly started server. And then clients can reconnect to that server. There's no state. There's no state, right? It's completely stateless. No messages in queues. This is why I said this is the trade-off. I can do this because nothing is kept on the server. It's just an endpoint which I can send messages to, and there's no messages in a store anywhere. Yeah? The client will have knowledge of which servers are in the mesh. And if it tries to send something to the server that is now offline, it will automatically reconnect and do a retry to that server. And all the messages, by the way, are of course replicated throughout the mesh. So if I send a message from this client, for instance, this client here, and I send it here, then it will be replicated to this server, and this client could get this message. But there's no state. That is why this works. So that's clustering, and it's pretty simple to set up. Like I said in the documentation, you only have to specify one other server, and then everything works out of the box. As I said before, you send messages and you receive messages through subjects. And I want to talk a little bit about that, how that works. And producers always send messages to a subject, and consumers subscribe to these subjects to get messages. Basic stuff. There's nothing more, nothing less. This is a picture of it. So I have two subjects. One is called temperature and one is called humidity. And if I, as a producer, send a message to the temperature subject, only consumer A and B will receive this message. And because they're connected to this subject, they're subscribed to it, and the humidity subject is not touched, then consumer C will not get this message. Pretty straightforward. A subject is identified by a simple string, but you can only use alphanumeric characters and the dot character. This is a bit special. I will get back to that later. A little tip, if you start experimenting with this, these subject names are case sensitive. Believe me, I have spent some time searching on why my messages were not delivered to the consumer. Make sure that you have the casing right. So that's a pro tip of the day. And like I said, this period is a special character because you can create basically subject hierarchies. So for instance, if I have a couple of stores, a couple in the US and a couple in Europe, I could create this type of hierarchy. And now I can send messages to a specific store in Seattle in the US, or the first store in Berlin in Europe, for instance. So you have some addressing going on, but this is purely on subjects. But there's a cool thing, you can use wildcards. And this is on the consumer side. So as a consumer, I can listen to multiple subjects at the same time by using these wildcards. And this is pretty handy. And there's one, the asterisk. You can use that to match a single element in this subject hierarchy. So for instance, store.us.star will you can use that to get all the messages that get sent to a store in the US. You can also do a store in the EU, but as you saw just now, in Berlin we have 2 stores. If I want to have messages that are sent to both of these stores, I have to do something like store.eu.***, because I need to match 2 single components in there, right? Pretty simple. There's also a way to, oh, sorry, question? No, it has to exactly match with this one, yeah. This is a great question. The question was, will store.eu.star.star also return eu.amsterdam? It will not, because it will expect another element after that. So this has to match exactly. But what you could do is this, and then you get all the messages sent to Europe, either Amsterdam or Berlin.1 and Berlin.2. So it will match multiple elements, but only at the end of the subject. As I said, these are the trade-offs. This is the simple, well, routing. You could not even call it routing, but this is some addressing that you can do. And if your solution fits this, it's fine. If you need more, then maybe NATS is not something for you. So please take that into consideration. Okay, so once we have set up these subjects, or we thought about it, this is just basically what you design as the application architect, we want to send and receive messages, obviously, because this is what NATS is all about. Well, the code that you use is pretty simple. You create a connection to NATS. Is that a question, or are you just bored? No, okay, sorry. You create a connection, use a connection factory, which is a class from the SDK, from the client. Then you create the payload, which is a string, but of course you could serialize some JSON or whatever in there if you want. Then you create a byte array with some encoding. In this case, I'm just using UTF-8. And then I'm going to say, on the connection, publish, and then I name the subject that I want to send this to, and the data I want to send. It's as easy as this. And then this will be sent to that subject on the server, and if a client is listening on that subject, it will receive this message. And this is what it's all about. So if I want to receive this message, I have to create a subscription on the subject. And I have 2 types. I have a synchronous one, and in this case, I create a connection with NATS, and then I create a synchronous subscription. As you can see, it's the same subject, nats.demo.pops up. And then I start my own loop, and I start waiting until a message comes in. And in this case, I'm waiting every time for 1 second. And if I don't get anything within this timeout, that is the 1,000 milliseconds that I specified here. If I don't get anything within this timeout, there will be no message available, and the loop will just go on. So this is if you want to have your own message loop, you can do this. There's also an asynchronous one, which is of course a little bit more elegant. Again, you create the connection, and once you have the connection, you create an event handler, and you will get the message handler event args argument, and this will contain everything you need to get from the message. And once you have this handler created, I create an async subscription using subscribe async. I tell it which subject to listen to, and I specify the handler. And this will automatically start a background thread listening to messages on this subject. So also pretty straightforward. Most of the time I do lots of demos and I show lots of code in Visual Studio Code, but this was so simple that I just put it in a slide because, yeah, there's not much to tell here. Okay. So now we can send and receive messages, which is also already pretty awesome, but we only have pops up, and we have at least once message delivery. And sometimes you need more. And this is really cool that you can do additional messaging patterns with basic NATS. So as I said, out of the box is just publish, subscribe, and fire and forget. I don't know whether a message is delivered to a consumer when I send it. It is just fire and forget. But you can also implement request response, and you can implement that using the reply subject feature. And I made a little animation of that, how that works. Let's say that I'm a producer and I want to send messages to nats.demo.requestResponse, and there's a consumer listening to that. So it has a subscription on this subject. What I can now do as a producer is create a new subscription, some temporary subscription, and in they are most of the time called _inbox and then some unique ID. And a really cool thing, you see a little one badge up there. What NATS supports is that you can create a subscription that will last you X number of messages. So in this case, I'm telling NATS, create a subscription on this inbox subject, but if one message comes in and I receive that, you can kill it, because I only need it for one response on my request, right? It's pretty simple. So then I can send a request, and in this request there's a field reply that I can fill with this subject that I've created. And then of course the consumer can pick up the message, can get this reply inbox from the message and send it back to me. And once I received the response, it is automatically discarded by NATS. So I don't have to do anything for that. So that's pretty cool. And now you have request response. So now you can know as a producer whether or not the consumer received it and sent you something back. So with this pattern, you can create acknowledgements. And you can have more security around, okay, is my message being handled by the consumer or not? So if you need that, then on an application level, you can implement this with NATS. And the really cool thing is that most clients also have automated this in a request method. So what we saw before, we did a publish, which is fire and forget. I publish it and then forget about it. But in this case, I do a request. And then this whole dance with the temporary subject and the subscription and all that stuff happens under the covers. And now I just get a response back. So NATS client handles that for me. And then with this response, I can do something. Yes? And this is what it looks like at the consumer side. There is a reply subject in the message, so args.message.reply. And if that is filled with a reply subject, I can use that to publish my response to that subject. Pretty simple stuff, but it works like a charm. Another cool feature is load balancing. So what I can do is that I can create a group of subscribers on a topic, or sorry, I have to say subject. And when I create a subscription, I can then specify this group. And if I do that, then if a message comes into the subject, it will be randomly divided over the connected subscribers with the same queue group. This is what this looks like. So I have a producer that will send messages to the temperature subject, and I have three consumers, consumer A and B, and consumer C. And consumer C just has a subscription on the temperature subject, but consumer A and B additionally apply the queue group with the same name. And if I now start sending messages, this is basically what happens. So consumer C, and yes, this is an animated GIF. You may applaud for that or not, but this is to make clear what happens. So you see that between consumer A and B, it's a random division, and consumer C will always receive the same message, a copy of the same message. So this is pretty powerful, because load balancing, this is something that you could need on your application level, and with this queue group mechanism, you can do that. And what does this look like in code? Well, it's pretty easy. I, again, create a subscription, just as I did before. I want a subscription on this subject, and then there's an overload in which I can specify a queue group name. It's just a string, and if you use the same name, you will be in the same queue group. Pretty simple stuff. And then the last pattern that you can build with this is scatter-gather. I really like this pattern, it's really useful. And what you then can do is use this auto-subscribe feature that I showed before, that you want to disconnect from the subject after X number of messages. You can implement this pattern. And this is what it looks like. I have a producer, and I want one of the consumers that are listening to the subject nats.demo.scattergather, I want one of them to send me a response back. And it would be nice if that is the fastest one. So it's the one with the lowest CPU consumption or whatever. But the first one that responds to me, I want to have that result, and the other one I want to discard. Well, that's very easy to build, because just as we saw with request reply, I create a temporary subscription on a temporary subject, and I send it in the reply field, in the message, and the first consumer that responds, I will pick this response, and then automatically this subject and the subscription is discarded. And if any other consumers will send something back, then NATS will just discard this. So this will not be a dead letter queue or an error or whatever. NATS will just discard this message. So in this case, with this pattern, you can just say, okay, I have several services running. I scaled them out because I need raw performance. And then you just get back the first client that responds to you, it's the fastest service, and then you have the optimal performance. So this is pretty cool stuff. And this is all like on an application level. So if you need this, you can just use the client to build this stuff. That's all I want to talk about NATS. Are there any questions on NATS or things you want to know? Yes. Sorry, I cannot. Can you use a mic? Is there someone with a mic? No, it's not possible. No. Because everyone that is, if I understand it, everyone that's subscribed to a subject will receive the message. Yeah.
Hello. Is there any way to apply message filtering to the subject? Let's say you use the temperature subject, and let's say you have temperature increased and temperature decreased. You have to do it at application level, right?
Yeah, application level.
Okay.
Yeah. So there's no filtering, nothing. And this is of course, like I said, the trade-off. But there are some cool tricks that you can do on an application level to do this, or you could divide it into several subjects. That could be the case. But yeah, there's nothing going on in NATS. It will just pick up an opaque byte array and send a copy to all the listeners. That's it. It's nothing more than that. But then there's NATS streaming. Oh, there was another question. Sorry.
Hello.
Hey.
Is there a size limit for the message?
Is there a size limit for the message? I don't know. I think there is, but yeah. Sorry? Yeah, you can configure that. I haven't looked into that, but
Okay.
yeah. And there are also other quotas, like how many messages can be in the queue and stuff like that for NATS streaming, but you can configure that stuff.
Okay.
Yeah.
Is there some overhead to subject creation?
Is there an overhead to subject creation? Yeah, minimal, but there will be.
Okay.
Yeah.
And who is responsible for creating the subject? Because you just showed that if one of the consumers tries to send a message to non-existent reply subject, it will be destroyed.
Yeah.
But I haven't noticed creating the subjects.
Subjects will be created
advance.
automatically. So if I send a message to a subject and it doesn't exist, it is created. The NATS server does that.
Mm-hmm.
And the same thing is for a consumer. If you create a subscription, it will just create the subject.
Okay, and if message arrives in subject that no one listens to, it will be.
It will be.
Okay,
yeah,
okay.
it will
Thank
be
you.
discarded. Yeah. Okay. So this was vanilla NATS. So this is what you get out of the box if you use the NATS servers. But there's also NATS streaming. And NATS streaming, which is also called STAN, if we look at the demo later on, you see the term STAN going on. That's the NATS streaming server. And this is basically, a streaming server. I don't know if people know Kafka, and I know I cannot compare these, but Kafka is also like a streaming server that you can use. It's basically the same idea. And it's just built on top of NATS. It's also open source. The link that you see here, you can see all the code. And this is how it works. So if you, from your application code, use the NATS streaming API, then it just uses a NATS client under the covers to communicate to a NATS server. And then this NATS server communicates to the streaming module. And you can understand now how this works, right? So the streaming module will just have a subscription on some kind of a subject. And when something is sent to this subject, the streaming module will pick it up. And this streaming module is responsible for the messaging subject, or the messaging pattern in streaming server, which is at least once delivery. So it stores messages. So here, it is basically more acting like a real broker. It will store the messages, and if I, as a client, am offline at the time of the message coming in, and I get online later on, I will get the message from the queue, and I can handle it. So it has state. So this works a little bit differently, and it's basically just built on top of NATS. These subjects that we've talked about if we talk about NATS streaming, they are called a channel, and this is of course obvious because now it's more of a queue that contains messages. We call that a channel, and it has a first in, first out message log. And this is the first thing that you get, because now you can actually queue messages while you're offline. They are never removed from the queue, only if the queue, because there are some quotas on it, what I just mentioned, if the queue is filled up, it will start overriding messages from the beginning, right? But if you stay within the quotas, then these messages will just stay in the queue forever, as long as the server is up and running. And also when it restarts, of course, because it persists all the messages to disk. But they will not be removed automatically when you deliver them. So like I said, now you have at least once messaging semantics, because also some acknowledgements are going back and forth. So the NATS streaming server will make sure that if you as a producer send something, that you know that the consumer got the message. And you can do that automatically, so you can have NATS automatically, the NATS client automatically send acknowledgements, but you can also do it yourself. And this is pretty important, because what you can do is you can get a message and then not acknowledge it yet, start processing the message, and if something goes wrong, you just don't acknowledge the message, and then it will be automatically put back, and it will be automatically available for the next consumer that needs it. So as you can see, this gives you way more flexibility and way more features than the vanilla NATS server. The cool thing about these messages staying in the queue is that you have replay functionality. So I, as a client that have never communicated with a subject or a channel that is up and running, I could connect to it, and then I can get all the messages that was sent to this channel from the beginning on. But you can also specify where you want to start. At a certain place in time, you can do that by, for instance, specifying a sequence number. Every message has a sequence number. Or you can say, give me all the messages from the last 10 minutes, or since January 1st, or there are all kinds of ways that you can specify where you want to start reading in this, well, yeah, basically event stream that's in a channel. If you make a subscription for a NATS server, NATS streaming server, you have three types. It's the regular one. This is just a subscription that will get the messages from a starting point. But then you, as a consumer, are responsible for maintaining the place you are in the queue. So if there are 100 messages and I've read them all, if the 101st message comes in and I was offline, for instance, and I get restarted, then I'd have to know that I have to start reading at the 101st message, right? If you create a durable subscription, then you can specify an additional durable name, and then the NATS streaming server will take care of that for you. So if you reconnect at a later time with the same durable name, then it will automatically resume reading at the place you were in the queue, which is pretty powerful stuff. And then the trick that I showed you with load balancing, with the queue group, that's also possible with NATS streaming server. Works in the same way. You specify the queue group, and then the messages will be load balanced. Unfortunately, for NATS streaming, there are no wildcards. So every subject is just the subject that you listen to, and that's it. This also means that for every subject that you want to get messages from, you need to create a subscription. So this is basically what NATS and NATS streaming are and what they can do. And now I want to walk you through an application that I've created using NATS and NATS streaming. And it's a simplified demo. It's a microservices-based application, and it's kind of a bookstore application. It's really simple, so bear with me. It's all console applications, but it's more about the concepts. And what I've done is I've used event-driven approach and CQRS as a pattern. And for the people that were in Gilles' talk here just now, he also mentioned CQRS to create some loosely coupled services. And I will walk you through the solution architecture. So there are basically three running parts here. I have the store application, which I as a user can use to order books. I have an order processing service. This will process all the orders and put them in what I call the write model. So this is basically my log of all the orders that I have. And I also have a query service, and this will create the read model, which I can use to query and look at my my orders. These services will be used from the store app. So to let these services communicate with each other, I just put in between a NATS server. And when I order something, that's a command, like order a book or whatever, I just send a message to NATS, and I have the order processing service listening to subjects. And it will just be sent to the order processing service. And then the order processing service will send the result back. And this is fine in this situation because if, for instance, my order processing service is offline, then I send the message and I get nothing back. I get a timeout and then I say, okay, probably the processing service is offline. I don't need to have NATS streaming, for instance, because yeah, it is just a message that I sent and I wait for the response. So NATS is fine for that. The same thing, I do the same thing for the queries. So I send a query to NATS. It will be picked up by the orders query service and it will send the results back. It's all just strings going over the line here. There's nothing fancy going on, but this is how this works. Then it becomes very complicated because, when an order is processed, I need to update my read model. And everyone that's been working with CQRS, this is eventual consistency. How am I going to do that? How do I get these events from the order processing service to the order query service? Because here I need at least once delivery. I need to know that this happened. Because if not, then I will be inconsistent. I have a different view on the write side than on the read side. So this is where I need at least once, so I use NATS streaming for that. So every time I do something in the order processing service, some business event is created. This is sent to NATS streaming, and the orders query service will pick up this message and will handle that. So if my orders query service is offline for maintenance, and it will come back online, it will just pick up all the business events that came in, and will handle these. This is pretty straightforward, and one of the things that I needed to find some protocol to work with this, and because NATS is so simple, you can think of all kinds of cool things to do. So for instance, when I send a command, the receiving party needs to know what kind of command this is. Because I can use wildcard subscriptions on a subject, I just put the type of the command and the query into the subject. So I can send to store.commands.createOrder. I send a create order command, and then the order processing service will listen to store.commands.asterisk, and it can just, from the subject that it gets in, it can determine what kind of command is in the payload, and it can interpret that. So pretty easy stuff. And then I've created a very complicated protocol for sending the payload, which is just I take the value of some fields, like an order number or a product number, and I just separating by a piping sign. Whatever. And it's up to you, right? So it's just strings, it's opaque bytes for NATS, so you can put in there what you want. And this is, for instance, the payload for an order product command with, for this order number, I want to order this product. So pretty straightforward. This is for the commands and the queries. For the events side, I use NATS streaming. So I don't have any, the wildcard feature. So all the events are just sent to a single subject in the NATS streaming server, which is store.events. And here I've chosen to, this is another, protocol. I don't know if you can call it a protocol, but it was my brain fart. I said I will just put in the message the type of the event, then a pound sign, and then the payload serialized to JSON. Right? And I'm not saying this is very good production-ready code, but it's more about that you're able to use the protocol that you want. And this is the one that I chose for events. Right? So, mental note of this picture. We're going to go to the code right now. And so I'm going to change to Visual Studio Code. I will give you some time to get used to the wide screen. And let's look at this. I have NATS running on my machine and NATS streaming. I will only show you these very uninteresting console logs, but it's just two processes running on my machine. But it's basically the NATS and the NATS streaming server. And what I'm going to do now, I have created a script to start my demo, and it will start 3 .NET Core applications, console applications, which is the store app, the processing service, and my orders query service. And I will put them somewhere on the screen that I can use them. Bear with me. I'm not a UI designer, so this is hard for me. So, something like this. And what I can now do, if I go to my store app, and you could imagine a very nice, nifty website, of course, in Angular or whatever, I say I want to create an order number 1, 2, 3. And what you see now is that the order processing service picked it up, so it sent it through NATS. It sent me back OK, that's over here. It's just a string, so I know everything went well. And also you can see that the orders query service received the event order123 created. So this works. And what I can now do is, for instance, order a product for order123, and I say, well, just give me the pragmatic program. I like that book. I want that one. And I also want, let's say, domain-driven design, 2, Eric Evans. So this is how it works. And every time I send a command to the order processing service, it gets handled, the write model has been saved, and then the order query service will be receiving an event. And if I now go to the database, because each of these parts in the application have their own database. So the write model has its own database, and the read model has its own database. And if I now do a query on the write model, what you can see is that I've used event sourcing, my own implementation of event sourcing, because I already have events that I create. So the state on the write model side of my order, basically my shopping basket, is created by saving all the events that happen with this order. So you see here, order 123 has now current version 3. So there were 3 events, and you can see them here. Order created for order 123, product 1 was ordered, and product 2 was ordered. Pretty straightforward stuff. And if you look at the code for this, because it's pretty straightforward, I'm using NATS for the commands. So if I open the bookstore app, what you can see here, this is my menu. So this is my cool website. I read what the user wants. And then based on what the user did, I execute some code, create order in this case. And then, just as the code that you saw earlier, I will create some payload. It's just a string. In this case, it's just the order number. And then you can see here that I build up my subject using the message type. That was the trick that I did, because on the other side I can listen to the asterisk, to the wildcard. And then I will send it to the server using the request method. So I will get something back, and this will, under the covers, will create this, this temporary inbox. It's as simple as that. That's all there's to it. If we look at the consuming side, so the order processing service is a little bit more complicated, but not that much more. And let's start in the start method when it's created. I have some SQL Server repository, which you will understand because I saved some stuff to SQL Server. That's all basic entity framework stuff. But this is where it becomes interesting, because this order processing service has 2 connections. One to NATS for receiving the commands, and one to STAN, or the NATS streaming server, to send events. And once that's up and running, so I have these connections, then I create a command subscription on store.commands.star with the wildcard, and then I want it to call command received method when something comes in. And this command received method is pretty straightforward. So according to my protocol, I take the args.message.subject, and I take the last part because that is my event type or my command type. And then I just do a switch and I say, well, if it's create order, then call the create order method and send in this message data. And this create order is pretty simple. I will just get the data from the message. I get my order, the current order, which is basically my aggregate from the database, and then I handle the order. This is all done in my domain. So for the people that were at Gilles' talk, we didn't rehearse this, by the way, but it's a great fit. This is the core, right? This is my domain. It handles, it does some invariance and business rules checks. And if that all works out, I get a command handling result. If that is successful, then I will update my repository. This will put the event in the database. And I will publish a business event. And this business event is pretty simple, because what I do is I create an event, and this is just a POCO, right, with some properties. I serialize it to JSON, and here you see the other protocol. I put the event type and the field values in the payload. So I put in event type, a £, and then the event data, which is my JSON. I create a byte array to make it a message, and then publish it to store.events. And this is where it gets picked up by the query service. Right? So this is pretty straightforward stuff. And all the code that I show you, by the way, is up on GitHub. I will show you a link in a minute, so you can also do this at home if you want. One thing I want to show you is that the query service also works. So if I say show the orders overview, that you can see that my order is in there. It's now in progress, and it has a total amount. So everything that I didn't build web APIs, I didn't do any gRPC, shenanigans, whatever. It's just NATS sending strings back and forward. And you can create an application like this. And this is, of course, pretty simple, but it's also pretty powerful because it's simple. So you basically can do whatever you want. And then if this fits for your purpose, then this is great stuff. Yes? The last thing that I want to show you, because if you have this NATS server up and running, you want to monitor this. And the cool thing is that monitoring is built into NATS, but also in a NATS way, like it's pretty simple and easy. If you start the server, you can specify a monitoring port, and then monitoring will start, and you can listen to it. And then you can find all kinds of variables, connections, the routes that are created, all the connected clients. It's just a RESTful API that you can call, and you will get back some JSON. That's it. So it's really in the NATS philosophy. It's really really easy. So let me show you how that works. I'll go back to Visual Studio Code, and I will start my monitoring. It's like this. So this is the basic one that you get. So you have a website. They did put in a logo, which is already pretty elaborate. But if I, for instance, say, okay, what kind of connections do I have? I just get a bunch of JSON. But we're all developers, right? We can create anything from this. So I really like this elegant simplicity. But you a little bit on your own, and you have to create some stuff around this to make it work. This is the monitoring of the vanilla NATS one, so I can see all the subscriptions, for instance. Well, in this case, I don't have many. There's also one for streaming. If I go to the same port and I go to /streaming, I get information of my NATS streaming server, but this has some additional stuff. So, for instance, if I go to the store, then I can see that my messages are stored on file system. And this is a provider model, so you could also store your messages in a SQL Server or whatever, but this is where these channels are being kept. And we talked a little bit before about the quotas. Well, here you can see some. So there are max channels, max amount of messages, max bytes, and all that stuff. But this is all configurable, of course, within the limit of the resources on the machine. Well, like I said, this is just JSON, but you can do stuff around that. So there is one open source project that I found, which is NATS board. And this is just, I think it's Node.js, but I'm not sure. You can just clone a repository and then do npm install and run it. And then you get all this information in a nice dashboard. Rather nice dashboard. But it's a little bit better than just looking at JSON. So they interpret the data, and they made some nice tables. You can see all the routes, but the really cool thing is that they also had some dashboard that will give you how many messages come in, how many CPU am I using, how many memory am I using. I don't think this is a production-ready thing that you would use to monitor a production system, but it's a nice thing to see that you can do this fairly easily because there's not a lot of code in here based on the standard monitoring endpoint. Let's go back. So, to wrap it all up, like I said, NATS is very performant. It's a messaging infrastructure, and it's really nice to build cloud-native distributed applications. It's simple, it's lightweight, and it's resilient. And you can choose for NATS or NATS streaming based on what you need, but you need to make sure that you have your messaging requirements clear. So do you need at most once, or do you need at least once? Do you want raw performance, or do you want message persistence and replay? And then there's some scale that you can play with, and then you have to find the sweet spot for your solution. Make sure that you understand these trade-offs. So don't send me an email to say, well, we've had this elaborate scheme and it doesn't work with NATS. Make sure that you know what NATS can and cannot do. It is all perfectly described on the documentation, so dive into that. And make sure that you use clustering to make sure that you're also resilient. Check out the documentation. It's on nats.io. You can find some information on NATS itself and also the documentation. If you want to play around with the code that I showed you, go to my GitHub repo, github.com/edwinvw/natsdemos, and then you can find it all. And with that, I would really like to thank you and have a nice conference. Thanks. I have 24 seconds for questions. So run to the mic. Because if my price? Yeah, there's a company, Synadia, I think. I haven't looked at pricing. No.
Does it support transactions out
Nope.
of the .NET code? No?
Nope.
Okay.
I will probably, for all the questions, does it support? I will probably say no, but just try me.
So the same question about ordering?
Sorry, ordering?
Ordering?
Messages are ordered per producer on the subject. Yeah.
Can messages have metadata also?
No.
No.
It's just a plain byte array. Yeah. But you can, of course, create your own envelope and then put the payload in there. That's up to you. But for NATS, it's just bytes. There's no metadata in there. Okay, thank you.